Right, grade 9. So this week we're moving on to Unit 3, Electrical Systems and Control. And there's a few things that tie into this unit. So we're going to look at components of electrical appliances, switches, diodes, and LEDs, as well as transistors. Right, so the main focus for this week is we're going to just break down quickly what is an electrical system, and then we're going to focus on the different types of switches that we get. Alright, so if you want to pause the video in the meantime, grab your textbook. Please open up to page number 78. And then we'll work through this together. Once you've read through everything in the textbook, I'm going to tie everything together, and I'll just summarize everything onto a page for you. Okay, so page number 78 says your components of an electrical appliance. So firstly, we need to know that an electrical system is comprised of many components that work together, all right, in order to get an outcome. So when we break this down, it says here that an electrical system, for example, an appliance like a kettle, is part of a large electrical system. It says electrical systems always have an input, a process, and an output. So as we know, the input can either be in the form of electrochemical energy, so that might be a battery, all right, it could be also in the form of normal electrical energy that comes from a power station, and that's also referred to as a generator. So it could be a petrol generator. Anything that generates electricity using fuel would be a generator. And then the last one being photovoltaic cells from a solar panel. So it's either one of those three inputs that we're going to be looking at in an electrical system. And then there's a process. So the process that we're talking about here is the conversion of that electrical energy into something else. All right, so in grade 7 and 8 you learned about potential and kinetic energy. So we're looking at that potential electrical energy being converted into a form of kinetic energy. All right, so this is the process. And after that conversion takes place, we get an output. So the output will be either in the form of heat, light, sound, or movement. Okay, so for the kettle, they break it down here for us. They say, what is the input? So what makes it work? It is electricity in this case, because it's plugged into the wall socket. All right, what is the process? So how does it do its work? What causes the kettle to boil? It's a conversion of electrical energy into heat energy. Okay, so what is the output? So what is happening during or after the process? We can see that the water boils, and that's because there's a generation of heat. So our output is heat. And as you know, there'll also be a bit of sound, because you can obviously hear a kettle boil, and as well as movement, because when the kettle boils rapidly, it will start to move. Okay, so that's just breaking down the components of an electrical appliance or an electrical system. So always note that there's an input in the form of energy. All right, that energy obviously has to be conducted via the electrical system through conductive wires. Then there's a process where the resistor or whatever the appliance is converting that input energy into an output of either heat, light, sound, or movement. Okay. So now we have to look at how do we control this system. All right, so that's where the switches come in. So on page 78 still, we'll see switches. Switches are viewed as an input and a control component in a system. It can close the circuit, which allows the current to flow through. This is called the input component. All right, it can also break the circuit, and this acts as a control component. All right, so they just put it in highfalutin English, but pretty much all this says is that it either is going to open the circuit, or it's going to close the circuit and allow electricity to flow through. All right, so switches as control components. It says the most common control component that we get is a switch. All right, the purpose is very simple. It breaks the flow of current or allows the current to flow through. It says when the switch is closed, it means that it is on. All right, so don't confuse yourselves. A lot of times we get confused because our brain automatically says closed is not working. But in this case, with an electrical system and a circuit, as soon as we close the circuit, it means that electricity flows through and the circuit would be on, and it would create an output. It says when the switch is open, it means that it is off and the current will be blocked, and therefore no output will be seen. So they give you an example of a wall switch with a resistor, right, that offers resistance when it is turned. So some of you may have seen this in your houses before. You've been to a friend's house that has a dimmer switch. All right, so the dimmer switch acts as a resistor. This pretty much just allows you to control the brightness of the lighting that's usually found in a dining room. All right, so as you turn the resistance up or down, you're restricting the flow of electricity, and therefore the light will either shine brighter or it will shine dimmer. Okay, it acts as the same principle as a car radio, or any radio for that matter, as a volume knob. So if you turn the volume down, you are then resisting the flow of current to the speaker, so therefore it is less loud. Right, and when you turn the volume up, you're allowing the electricity to flow through, and therefore it makes it the speakers a lot louder. Okay, on the next page, on page number 79, also quite important, it's just important that you learn these off by heart. Okay, so you need to know the different types of switches as well as what they do or how they work and the symbols that are involved. Alright, so firstly, the most common one being a rocker switch. Alright, the rocker switch says that the description is the current flows through or is interrupted when the switch is on or off. And there's a symbol, this is the first one that you learn when you're in grade 6, is the standard rocker switch. Alright, then we have a pressure switch. Again, the current flows through when it is pressed. The current breaks when the button is then pressed again or released for that matter. Okay, so you could have one that clicks into place. So an example would be like on a lamp where you have a little button switch where you click it. Or it could be the case of where it's spring activated, such as a doorbell. And as soon as you press the button down, it will complete the circuit and the bell will ring. As soon as you release the button, then the bell will stop ringing because it then opens up the flow of electricity. Okay, the next one being a slide switch. Says here that this switch can be used to reverse the direction of current. For example, ceiling fans. Alright, it says the switch allows the motor to turn clockwise or anti-clockwise. So it just reverses the polarity of the circuit. Okay, it goes from it being from a positive side to a negative side, and therefore in turn it makes the fan turn in the opposite direction. And then lastly, we have the toggle switch, where the symbol, you can see it has two forms here. It says it is used to alternate between two different devices. So from one switch, you can control two things. So for argument's sake, you could have two light bulbs running off the same switch. And they could be both series circuits, but they both come on with the same switch, right? Or parallel circuits, vice versa. Another example, you could have one light bulb connected to this section and say a buzzer connected to this section, and one switch will control both. Okay. So this is pretty much what the textbook tells us how to revise. So there's just a few key things that you need to remember. Every time we have a circuit, alright, there has to be an input. The input in this case will be chemical energy because I'm drawing a cell. It could be in the form of electrical energy or photovoltaic cells. Alright, so this is the first thing that you need. That will go to some form of a resistor. So it could be a light bulb. And then this electrical energy that now flows down is then converted into something else. So this is referred to as the process. So this is the input. This is the process. Right, where this conversion takes place. And then this light bulb will give off light as well as heat. Okay, and this would be our output. Being heat and light. Okay, so again, let me just quickly draw this one last time. The light bulb. Right, and now we have some form of a switch. It could be the case of a rocker switch. Okay, or you could have a button switch. Sorry, a pressure switch that makes use of a button. Right, so when you push down on the switch, you will then close the circuit, and therefore the electricity will flow through. Alright, you could have the form of a slide switch, which has more than one direction to go to. So here's just an example of that. Right, so it will slide over to one side or the other, and this will just reverse polarity. You also get the form of a toggle switch, which we said has two directions to flow in. So when you turn the toggle switch one way, it will then connect both circuits in order to allow the electricity to flow through. Alright. So, grade 9s, don't forget this, just break it down quickly for yourself again. Electrical systems always have an input, a process, and an output. The output will be in one of those four forms: heat, light, sound, or movement. Okay, and how do we control these circuits? We control them using a switch, alright? And the switches can come in different forms. Each of them have their pros and cons, and you have to decide what works best for you. In a test or an exam situation, it's just important that you know what the symbols look like, because I could say, draw me a circuit that includes a light bulb, conductive wire, and a toggle switch. Then you'd have to include the toggle switch in there, or a pressure switch, or whatever the switch may be. Okay, but you guys are doing well. There's no formal activity with regards to drawing circuits. The only thing I want you to do is practice your switches and know them off by heart. So you're not going to be doing anything on this page. Page number 80, however, that's just the practicing of the switches. So again, you'd write them in here. This is activity 5, appliances. All right, and then just give me an example of where it may be used. I've already given you a few examples. You can use mine. right, and the purpose and the efficiency of the appliance, again, that it will be in your own words. So please read through page number 78 and 79 again and complete activity 5 on page 80 for me.